We want to solve quadratic equations by graphing and factoring. So we want to be able to solve quadratic equations by graphing and solve quadratic equations algebraically by factoring. So first thing we want to look at is the parent function of a line, and that is in the most basic form of y equals x. And when we have the graph y equals x, that is just a graph that goes in diagonal up through this direction in a straight line. And if we're looking at this, we remember, or we understand that if there's nothing written in the exponent, then it has an exponent of 1. And if we notice, a line only crosses the x-axis one time. So that would be our 0 for this linear function. At this point, the 0 would be 0, 0. That's the point where it crosses the x-axis. Well, for quadratic functions, the parent function is y equals x squared. And in this case, we have 2 as the highest degree exponent. For the linear function, we had an exponent of 1, so that crossed once. So with the parent function of the quadratic, we expect that it's going to cross twice. So the other thing we can look at is in standard form, we have ax squared plus bx plus c. Again, our highest degree is x squared, so we're expecting that this function is going to cross the x-axis twice. And these are used interchangeable, roots or zeros. The solutions to the quadratic function are the roots, or the zeros are the x-intercepts of the graph. These two mean the same thing. That just means where the function crosses the x-axis. So in order for us to do this, we're going to use the zero product property. And the zero product property means if a and b are expressions and a times b equals 0, then either a has to equal 0 or b has to equal 0. So here we have an example. So you have y equals x plus 3 times x minus 6. If we substitute 0 in for y, that means we want to find out when this graph is going to cross the x-axis. We can simply set each one of these expressions equal to 0. So 0 equals x plus 3, 0 equals x minus 6. We add 6 to both sides. We subtract 3 from both sides, and we get negative 3 is equal to x, or 6 is equal to x. So what that tells us is the multiplicity of the function. And what the multiplicity says is the multiplicity of each 0 is the number of times that its corresponding factor appears. So when we're looking at the example over here, we have y equals x plus 3, x minus 6. What that tells us is if we set x equal to negative 3, that's going to give us the point negative 3, 0. That's going to be a 0 or a root. So negative 3, 0 happens right there. If x equals 6, that tells us that we have the point 6, 0, and then that point happens right there. So those are the zeros. We can also look at our a value here. That will also help us. So in this case, a is equal to 1. So that tells us that our parabola is going to open like this. So I can make a quick sketch here where I just draw through my two zeros. And then we can see that if we have a multiplicity of 1, our function is going to cross the x-axis. Now if we look over here at example 3, we have y equals x plus 3 times x plus 3. Another way that we can write that is we can write it as y equals x plus 3 quantity squared. So in this case, both solutions to this are negative 3. So we get the point or the 0, -3, 0, which happens over here. Then we can take a look at our a value. We see that our a value is 1 for this as well. So we still know that our parabola opens up. And so we can sketch a parabola that opens up and passes through the vertex is located at the x-axis. So if we have a multiplicity of 2, that means the vertex is on the x-axis.